So for the gas laws the other day, we looked at each one of the gas laws, what they'd look like on a graph, and then talked about what their relationship was, what the formula was. So just a quick reminder, remember in Boyle's law, the temperature stays constant, and so the formula is P1 V1 equals P2 V2. So the first pressure and the first volume is equal to the second pressure and the second volume. Okay. Charles's law, the pressure stays constant. So you're thinking, remember, you've got a flexible container, so like balloons or tires or anything that can flex and expand so that volume can expand. In this situation, we have V1 over T1 equals V2 over T2, or the first volume or the initial volume divided by the first temperature equals the second volume or final volume over the second temperature. And then Gay-Lussac's is the last one that we've talked about so far. The volume stays the same, so this is going to be a rigid container. So like my pop cans, a 55-gallon drum, a Erlenmeyer flask, anything that's not going to want to flex whatsoever, it's going to stay the same volume. The pressure of the first pressure is going to be over T1, and it's going to equal P2 over T2, or the final pressure and final temperature. So these are the three gas laws that we've talked about so far, but they don't all just work by themselves. I mean, if we think about in your car in the wintertime, if the temperature goes down, we know that the volume will go down on the tires, but also then there's going to be a relationship to what happens to pressure and, and how temperature relates to pressure. So there's what we call the combined gas law, and the combined gas law is just going to throw these three things together. All right, so what we get in the combined gas law is you're going to get P1 V1 over T1 equals P2 V2 over T2. So basically what we've done is we've just put all three together, and that's why it's called the combined gas law. If P1 over T1 is, the relationship for Gay-Lussac's, and V1 over T1 is Charles's, notice these two guys are multiplied here, you just put them together, so we just combine it. So what we're going to do for a second is we're going to look at a couple problems. So on this worksheet, I'm just going to have you guys do a couple of these on your own to see how you're doing with this calculation piece. So question number 1, it says if I have an initial volume of 4 liters of gas and a pressure of 1.1 atm, what will the volume be if I increase the pressure to 3.4? So what I'm going to do here is I'm just going to erase this really quickly. And we're going to solve and try to figure out what are we solving for. Okay, so here's what I'm going to do. I have an initial volume, so V1 equals 4 liters. Okay, that's a period. Sorry, it's hard to do without the little pen. And the initial pressure is 1.1 atm. So our initial pressure equals 1.1 atm. Oops. Okay. And then it says, what will the volume be if I increase the pressure to 3.4 atm? So maybe I've got this hooked up. Maybe it's a basketball, and I'm going to be hooking it up to an air compressor or something along those lines. I don't know. There's a lot of things we could be doing with this. Okay, so the second pressure then is 3.4 atm, and we want to know what that final volume would be. All right, so I'm looking for V2. Now, setting stuff up like this may seem like it's a waste of time, but it tells us what formula we're using, because without it, we don't know. Notice in here we haven't talked about temperature, so that means it's consistent. So we're looking at a Boyle's law, where we know P1 V1 equals P2 V2. So I'm going to take P1, so 1.1 atm, okay, times the 4 liters, that's a 4, sorry, it's hard to tell, equals 3.4 atm, and we're not sure of the final volume. So question mark liters. Okay, So we're just going to solve here simple algebra. We've got 1.1 times 4. So I'm going to bring up my calculator. So 1.1 times 4 equals, okay, 4.4. And then to get liters alone, we're going to have to divide over this ATM. So divided by 3.4. And we end up with 1.294. Sig fig wise, we're looking at 2 is the best that we can do. So we're going to come out with liter for the second volume would be 1.3 liters. All right, now let's just kind of rack our brains around the conceptual part of this. In this situation, we see that the pressure went up, and we know that from Boyle's law, they're inversely related. If one goes up, the other one goes down. So since the pressure went up, we'd expect to see the volume decrease. We saw the volume decrease in 1.3 liters. So this is an example of how you would do these gas law problems. I'm leaving some of these gas law problems for you guys to work on today. And then I am going to have a quick little video showing you how to do this for one of the combined gas laws. I'm sorry for the time it takes and the kind of messiness, but I don't have all my tools with me to do these videos, so I'm just trying the best that I can to help you guys out. If you have questions, send me emails or stop next door and talk to Mr. Young. He knows that I'm not around tomorrow, so he can help you out if something comes up. We will test on Friday, but I promise Wednesday and Thursday we'll get you guys in a good position to be able to put all this together. All right?